All right, greetings and welcome to another glorious day of microjam week. We're on day 3. We're getting increasingly technical as the time goes by, so thank you for joining us for this awesome opportunity to basically learn everything you need to know about Big Bang before you use it for Global Game Jam. But speaking of Global Game Jam, I've got some cool announcements. So our Global Game Jam virtual site is live. If you don't know what that is, when you do Global Game Jam, you have to have a site, right? And this could be like a real place where you go and you hang out with people and you jam together, or it could be just a group of people who you're getting together with on Discord or different ways to get together virtually. And we have our own Global Game Jam site. It is, yeah, here we go. It is not, it's not required for you to use Big Bang. You could go to any site and use Big Bang, but if you want to have a little space where you've got people who are all supporting you and we're there and we're all hanging out and we're game jamming together and all that cool stuff, it is available and you'll find all of the links, info on how to join it and stuff here. So let me post that in the chat. Also, welcome everybody who's here. It's good to see some familiar faces. Corey D Animates, good to see you. Welcome to the stream. We're going to be talking about using Big Bang for your jam. Specifically, we are making a custom player controller today. So I don't know if this is any clear indication of what this is going to be, but let's save and go. Yeah, we'll just use this multiplayer link. Okay, so if you would like to join me in this project, this is your opportunity to grab some things, show them really quickly, and also let me put this here on Global Game Jam. So we're on 2 places. Hello if you're seeing me from the Global Game Jam Twitch, and hello everybody else who I will be seeing on the Big Bang YouTube. We're just in lots of places. So welcome everyone. And you might have noticed there's a little bit of a theme of what we've staged going out here. And that is, how do I pick this up? Do you just bounce off it? You don't actually attach to a player? Oh, interesting. But yes, this is the theme. Pogoing is the theme. Welcome to the land of Pogo Stick. We've got our celebrity right here, the Pogoist of cats. I should just make him a voxel player and then we could all become Pogo Cat. But we're going to be doing a lot of scripting today. So get psyched. It should be really, if you're not used to it, it should be easy to follow along. I'm going to be simplifying a lot of things and it's going to get more and more complex over time. So stick with it and you'll have something no matter what. And the deeper you want to get in, the more you can learn about good ways to design code in Big Bang. Boing. I've just picked up the jump boost permanently. I see. Well, that's glorious. This is the future we wanted, is it not? Yeah. So that is that. You're welcome to join me, but once you're here, you're going to see the project that we're actually going to be making, which is over here in PogoCat. Please teleport me to the right place. Please teleport me to the right place. Please teleport me to the right place. It would just be if I put the link in incorrectly. Okay, and we are now in PogoCat. We are in multiplayer PogoCat, which is actually probably it seems to work just fine. The version that I'm working on will not work like this unless we get that far. But I've cut it down a little bit, and dealing with some of the multiplayer things is the thing. But yeah, I don't know. We can make this a competitive game, right? I don't know if coin capture is networked or not, but you could do it and make it, the most coins wins, like a little, I know I keep talking about Mario, but it feels like a Mario Party mini game, doesn't it? So yeah, we could probably make a bunch of Mario Party mini games. That's a jam for another time. Mario Party mini game jam. So yes, this is what we're making. Now, I'm going to make it pretty simplified. There's a lot of things that we're just going to kind of gloss over, and you're going to see with increasingly laissez-faire attitudes, but this game is remixable. So I'm going to go ahead and remix it. Goodbye, friends. Goodbye, my glorious pogoing companions. This is not going to be as conducive to multiplayer editing because we're basically building a single player experience. And we're in Big Bang, as you saw from our glorious, beautiful workshop space, maker space that I just love more than anything. That you can make all these multiplayer experiences in there, but a lot of times with game jams, what people really want to make is something that's like very like standalone and isolated. And I think this was a really good example that you can make something that's essentially 2D, functionally 2D, although these are all 3D objects, as you can see here. Nothing truly 2D about this. But I love it so much. It's so good. But anyway, look at these clouds. They're so good. We can just whoop. Oh, okay, sure. That'll fit it to the screen. But yeah, so there's lots of options. Oh, my space bar is still pogoing me. Great, glorious. Lots of options on what that could be. But we are going to just explore this so you can see that your options are infinite. So to do this, I'm going to keep this guy here because what I want you to see is that if you want to just understand exactly how this was made, it's a little tricky because the little guy here is actually parented to the player, and the player you can't click. So go into your entity search if you're looking at this game right now and scroll all the way down to player. And in player, you'll find a script called Pogo Cat Movement. And this is basically what I'm going to be referring to and recreating today. But like I said, we're gonna make all of this make sense. Each step, you're gonna be like, I understand why we do this, and we're doing this for a reason, and that is because I'm gonna break a lot of things. Get psyched. Zaz breaks things is a essential step in Zaz codes things. It's my favorite way to do things. Let's break things and then see how we fix it. So that's what we're gonna be doing here. And so if you have your own remix, you can do that. But what we're actually going to do is start from a new game. If you don't know this, anywhere in the world, you can type game.new into your browser, and you're actually going to end up in the .big bang game editor. And we're going to just start from an empty game. So the first thing that I want to do, besides say goodbye to Bob the Builder, goodbye, Bob. Everyone say goodbye, Bob. F's in chat for Bob, please. Thank you. Saying goodbye to Bob the Builder is we're going to get that 2D camera in. And I'm actually not going to, so if we stop the game, we can actually just find the camera. The camera isn't like a template. It isn't spawned. It's just like an entity in the game. So it's very easy to edit. You can see that like all of the camera logic that you've ever seen is in here in DBB polar camera, DBB spatialized audio listener, aiming reticle, pointer, lock, and underwater camera effect. And so we're actually going to, we could deactivate. So if you're never sure if you want to delete a script or remove it, you can do this first and then delete it later. But what I'm going to do is I'm going to add a script onto this, and it's just the same one that Ashley made, I believe made for the Pogo Cat or made before for something else. But it's a cool little camera. So we're going to click open and you'll find Ash _ 2D. 2D cam, that's the one we want. So when we select that and we go back to the game camera, we'll find that, gloriously, we just can't move our camera anymore. Most of the logic in here would have been pretty easy to write if we did it. It's most of the code is actually for this, it being able to swap to a different target from the player. But we're not going to use that. So would be fine if you wanted to try to just make an unmoving camera yourself, or even fix it in place. But we need this offset, and you'll see why as I break things in the future. So when I press play, I the player can still move around. I thought I'd be visible. I was visible the first time I tried this. I think it's the offset. Oh, it's because it's -60. So if I set this to 60, yeah, then you can see me, and you can see the camera is sort of like is that orthographic? The camera is not moving, but it is following me. It's sort of panning to follow my direction, but I can't rotate it. Okay. So that's cool, but I'm not a Pogo Cat, so we need to fix that. So what we're going to do is we're going to search for the Pogo Cat. If you go to all and you type Pogo Cat, Pogo Space Cat, and I'll drop a link. If you've ever like got an object that you want to use in game and you don't like know how to find it in your editor, you don't want to type the name, if you, and I will drop this link in the YouTube, this is to the voxel object. It is remixable, so you could make your own custom Pogo cat for this. So that's in the chat. And if you ever were just like, oh, I want to use this in game, but I like don't want to try to remember to type the name, whatever it is, press this heart, like it. And then when you're in the game, you can also search for liked. And well, I've got Pogo Cat search on, but this will just show you everything you've liked before. And you can find it in here. Just another way to do it. I like a lot of things, so this might not be the best method for me. But as you can see, if I type yeah, I'll get to my Pogo cat. Yeah, got a lot of beautiful art on DBB. I'm no shame in liking all of the things that I do. Maine Coon cat loaf. How are you supposed to resist that? So you could make your own custom Pogo cat as we're doing this, and you'll probably have some time because we'll be doing some debugging and things like that. Okay, so here's my Pogo cat, and what I need to do is I need to make this the player template. So what I'm going to do is I am going to make a template. And so we'll make the new template, and I'm going to grab the name of the entity, which is the name of the voxel object, and just add player at the end so I can save that. So we've got Pogo Cat player, and then in the game save menu, if I click this, I'll open save options, right? If I'm in entity search or something like that, I'll need to click this to get it to save options. And if it's closed, you'll need to shift right arrow to open it up again. And in here, we've got camera is fine. And I want to change my player template to Pogo Cat player. As you can see, I've done this before. So now we'll press stop and play. And I am a static, unmoving Pogo Cat facing away from the camera. We did it. Glorious, glorious times. And that's just because of the way sort of like player spawning is working. You can also see like the spawn point is facing that way, like the little indicator for it. And also that our other Pogo Cat is here. So we're going to do a couple of things to change that. One of them is I'm going to add to this Pogo Cat a script. And this is one of the ways that we're going to be different from the original thing is I know a bunch of scripts that I can get to do work for me that I don't want to do for the stream. So we're just going to add them. I love scripts with specific functions that I can just use for the thing we do. So this one we're going to do DBB destroy if not player. Let's try not player. See what we get. Remove if not player. So this is by Jordy LaForge. You can select that. And so now if the game is playing, that Pogo Cat is gone, but my player Pogo Cat will still be there. But when I press stop, it's the opposite. My player one is, my template one is there and the other one is not. So now what I'm going to do, and if you see the reason I said, and I will be referencing this project at all, I'm going to get it out of multiplayer because I'm going to be coming in and out a lot. Let's go into edits. Wait, oh, this isn't the remix. Where's the one I remixed? This, no, that's the Pogo Cat. This is my remix. Okay, so we're going to take this one out of multiplayer. And we're going to close the original because you all have the link by now. And we'll make sure you have it. We've got docs, and we'll be talking about those later, but I'll put that in the end. Oops. Here we go. Okay. So this is going to be my remixed version of it. And if I look at this and I click this Pogo Cat, it just has no scripts or anything like that. And so that's the transform. But under transform, I can see that its parent entity is the player. So there's an invisible player, and this is in front of it. And if we could make that player visible, which we can, let me pull out player, and we'll see that the voxel object is hidden. And we can see, yeah, we have a backward facing Pogo Cat in this as well. So we're just going to do the same thing. We're going to spawn and parent a new Pogo Cat to the original. And in the original project, Ashley did this with a script, but I have a script for this. We use it a lot. So if you've ever played with, for example, the car parking, winter car parking. Oh, is it because I'm not in play? Winter car parking sign. Oh, I can't interact with it. But if I were to look at what this does, right, it's going to spawn the car that you can see in the picture. But if I were to look at this, the only script it has is spawn on interact. And so what it does is it spawns something else, right? You can get there are a lot of different times you'd want to use a script to do this. So this one, I'm just going to give one of those scripts. So we will, this is mine. Okay, yeah. We are going to open a script, and it's going to be called spawn. It's a DBB spawn. DBB spawn. Where's my script? Spawn and parent voxel object. This is what we want. So what this does is most of the DBB spawn and parent, you have to make a template of it, but I'm lazy and I don't want to. And literally the only reason I'm doing this is for the art. So this seemed like a logical thing. We're going to go Pogo and we'll grab the Ashley K one since that's the one we're using. And we're going to spawn and parent a Pogo cat. So now, if I save and stop and play, remembering to save, it's hard to tell, but let's go into fly camera, or really orbit camera is what we want, huh? Why is this never the button? I think it's going to be, okay, here we go. Okay, I'm not even sure it did spawn and parent. I think it did. Oh, no, it didn't. One, I tried to add it to a template. So we need to be editing this one. We'll do it while the game is stopped right now. But we'll open that script again. It should be up here. So we'll add that. We'll pick our voxel object, also in recent items. Oh, very nice little quality of life features. And then to make sure that I can see what my cat is doing, I'm going to take this voxel object Pogo cat, and I'm going to just take the opacity down. So it's a little ghosty cat. Little ghosty cat. We're going to now, what we need to do every time we edit this and want it to be the player, we need to make our changes apply to the template. So that's going to be in the entity section. And, you know, if you saw the stream that I did on Monday, it was a lot of this, but it's push to template, save. And then when we interact with the template again, the template that spawns will be the one I use. Use computer. Missed something there. Okay. I mean, unless it's just you're saying use computer. Okay, so what we can see basically is that this one that spawned is also facing the wrong direction, but we have settings for that. So we'll press stop. We'll click our little ghost cat. And in this one, the rotation, we're going to change the Y to 180. These are degrees. And then when I press play, and then when I push to template and press save, when I press play, I'll have a forward-facing Pogo cat and a ghost backwards-facing Pogo cat, which you can see. See the two Pogo cats? Okay, so let's do something that removes the first Pogo cat instead of making it invisible. So to do that, I'm going to add good old DBB Gizmo. So this is a useful script when there's something that you edit a lot during the game, and then no longer want to, but don't actually want to show up in the game. So it's like, say I've got like a script that doesn't need to be seen at all. I could put it on something that I then make invisible during the game. And you'll see that like if you open combat game, there's a lot of things that you can't see and that until you press play. Oh, actually, well, there would be. It's deactivated on a lot of them, but you'll see this in a lot of like games as people make them. So I'm going to add DBB Gizmo. And what this is going to do is it's going to hide the voxel objects on play. And if it had text, it would hide the text. And so now this guy is, well, it's deleted during the play. I didn't push the template. You can still see him as a cat. All right. So we need to push to template again. So we're going to basically add that user script that removes the voxel objects, and then it spawns a new one and parents it, and that doesn't get removed. So, and that's the glorious future we want. So when we press play, we've got 0 ghost around the cat. The remove if not player is also gone. Everything is great. We're doing fabulous, other than the fact that our Pogo cat does nothing. But that is fine. So yeah. Okay, so now what we want to do is to add a script that we actually program to make it do things. I can take off this kind of funky transparency that I was doing while I was working on it. We'll just take that opacity back up in the voxel object section, and we're going to add our own script. So I'm going to tell you a secret. If you've been in Big Bang for a while, you've probably done this thing where you wanted to open a script, but you created a new script. And so you have a bunch of scripts called unnamed resource. So if I were to just look at mine, right, which is unnamed resource for days. So usually when I'm actually on purpose trying to add a new script, I just look up one of these other ones. And unnamed resource, if it's got 42 and some number as a variable, I just didn't add anything to it. So that's great. Perfect. And we'll just rename it right away, right? So we'll call this Pogo cat controller. And I can make this published and usable by others. And you could also look at mine later if you'd like to. But that's what we're going to do. We're going to just take this 42 out because that way I'll also be able to tell later in case I forgot to rename this what it is. So Control S, when I have the script editor focus, saves the script. It does not save the game. So I'm going to go to the game and I'm going to save that as well. Okay, now that I've added this to PogoCat, I'm actually going to update the template right now because when the template will have a reference to the script and the script can change, but I won't have to push those changes to the template for them to apply. So my life is about to get a little bit easier, especially as someone who you can see consistently forgets to do this. So entity section, scroll down to the bottom. We're adding a user script component and fixing the opacity. So we're going to push to template and press save. And life has just gotten a lot better. We're now going to have a fabulous Pogo cat. Okay. So what we want to do now, oh, I wish I had my, where are my notes? Oh my goodness. Okay. So what we want to do now is, oh my gosh, put this here, is we're going to just create a variable. We're going to apply a velocity change to it. So we're going to create a private variable. And when I make private variables, I'm going to use this underscore thing. That's a convention. It doesn't actually do anything. It just sort of like signals that this is a private variable. It makes it a lot easier to read in your code which one that is and what your intentions for it were. And this is going to be called target velocity. And target velocity is going to be a vector 3. And that's because even though we're pretending this is a 2D game, right, at the end of the day, this is like a 3D object. We're just going to be moving it into dimensions as we've seen going through it. So we've got a thing called target velocity. And if we make a new vector 3, that's the same thing as a vector 3, which let's go ahead and just start on the docs now. And we'll pull up the vector 3 right here. And I'll paste that to my 2 locations for anybody who wants to follow along in docs. I'm going to be pulling up docs the whole time so that you can see. Hello, Sonic. You are super cool. And James, lovely to see you. Have a great time. We can nerd out further. Friday is going to be our nerdiest day, so get excited. It will not be me, but the illustrious Shirley, who's worked on far more big Big Bang projects than I have. So it'll be a really great time for seeing some cool Big Bang coding things. Okay, so this is just our vector section. We're basically going to see vector has 3 components. It's x, y, z. It's the same as vector everywhere. I was about to confidently say which value is up, and then just doubted myself in my heart, so I can't say for sure. So anyway, we're going to make a vector 3, and in our tick function, we are going to add it to our Pogo cat's position. So Pogo cat is going to say is this is the entity. So this dot entity is our Pogo cat player. Dot get world transform dot. Oh yeah, we're just going to add the X. Is that what we do? Oh my goodness. I closed my test project for this and now I'm completely confused. Just a moment. Where are my notes? I have a careful, very clever way to approach this. You ever try to open a game? Somehow delete it? There's no way. You can't delete them. Okay. So what we're going to do is I'm going to pull up. We've got a target velocity and we're going to add it to world transform. Everything's still going, right? Okay, good. Sorry. So this entity, this is the script. The script belongs to an entity. That entity is called PogoCat. Inside of PogoCat is a thing called a transform. Transform has 2 versions, local and world. We're using world. And we're going to add a dot position. To the position, this one right here, we're going to add this vector 3 we just created called target velocity, which is this dot underscore target velocity. Tab to autocomplete. Life is great. This is a good editor. So this is what we're going to do. I'm going to press save and press play, and we'll find that absolutely nothing happens. However, what I can do, and I could make this a public variable. Actually, it is a public variable, isn't it? Let's go ahead and find our player. Because I didn't actually say private. So target velocity, even though I use this underscore, I didn't actually make private. So if we were to say add a little bit to the Y, right, we'll find that, PogoCat is somewhere in space now. We can actually make it slightly negative, and PogoCat should come back to us at some point. Let's see here. Where are you, PogoCat? Oops, went through the floor. Let's do a game camera so we can see. Yeah, now we're going negative. We can go back up. And we're moving positively. And that is, well, as far as you can tell. And we'll head back down. So we can basically, now we're just adding this velocity to this thing. So what we're going to do before this is sort of every step involved in keeping, in setting this vector 3. So what I'm going to do is I'm going to put this back to 0. And then I'm going to write private in front of this. And what that's going to do is it's going to keep me from being able to change in the editor, because this is something we want to change in our code, but not change in a menu. And you'll see opportunities where sometimes we do want to change it in the menu, and it's very convenient. It lets us tweak values and things like that. And if you've been using really any game engine, you have probably things that are exposed in your like UI from your code. I mean, unless you're using like a blueprints or something. I don't know if they do that. I guess they are that. But But for the most part, this is a pretty common pattern to have it. It's very convenient when you get good at it. So this will help us in the future. Okay. So we've got a target velocity, and we're going to basically change this based on what direction the player is going. So what we want to do, am I not logged in? Yeah, it's like my game disappeared. Okay. Okay, so what we're going to do is we're first going to figure out what the... Okay, oh my God, my notes. Thank goodness. Been struggling. Okay, so what we're going to do is we're going to figure out sort of what direction, if we look at sort of how PogoCat works in the original game, essentially your mouse directs which direction it's going to jump, and we'll eventually have an arrow for that, but that's kind of a last step. And your space bar to make it jump is what kind of gives it how high it's going to go. So we're going to work on that horizontal component, right, the direction, and then we'll do the how high, and then we're going to make these values make sense. So what we're going to do is we're going to add another variable called, another private variable called launch direction. And it is a vector 2, right? Or no, it's just a number. Okay. Because this is just basically the horizontal component of the whole thing. So in the tick function, right, we're going to start with figuring out, let me just, arrow. So when you look at Big Bang games, we sort of think of them in a 3D space, but we're going to use the 2D space that is the canvas. So it's going to be basically all of the space outside of here that we use. And we're going to get the canvas size. So to do that, you can get the canvas size from the game renderer. So if we go to, all right, it is game objects, game, and inside of game, there is a thing, property called renderer. And if we can, from here, we can see that this has different information that you can get about like how the game is being rendered. But one of the things that you can get from it is get canvas size, which will basically tell you how many pixels are in the canvas. So is it pixels? I think it's pixels. Yeah. Let's say. Yeah, so it's coordinates, which I believe are pixels. Okay, so we are going to... Am I in the wrong version? Okay. Where's my... Oh, that's right. I hit it. Okay, so what we need to do is get the canvas size. So we'll say... this is just a variable we're going to use in tick, and we don't need it anywhere else, so we don't have to do it at the top like we do, and it's not going to change, which is why it's a const. This dot game dot... Although it's in... Okay. Get canvas size. Okay. So we used this variable here, get canvas size. There we go. Yeah, CSS pixels. There we go. I was just looking at the wrong section. Okay. We're going to close the Global Game Jam site tab, so I stop opening it. So this just gives us the canvas size. And then to figure out where the mouse is, we can use an input thing. So we're going to say mouse position, and this will be a vector 2. And then from here, instead of looking at the renderer from game, we also have a thing called input. And we can look at input, and we'll see here that we've got different options. We're going to look at the mouse option. I think in the full version of this game, you can also do it for mobile and with a game with one of these controller. But what we're going to look for is mouse, and we're going to see we've got like is button pressed and get position, and that's the one we want to use. So It's going to be this dot game dot input, like we saw, dot mouse, and then get position. And you can see that like as I go, I get each option. So from this dot game, I can press dot and it'll show me input, and from there I can dot and it'll show me mouse, and from there I can dot and we'll get position. There we go. And this is going to return a vector too. So we can see there that it's a vector too. Okay, so we're going to use the mouse position. And then to get the direction, we're going to say, okay, if this whole thing is a canvas and 0 is the center, then I know, or I can figure out basically if it's left or right by deciding if it's bigger than half of the size of the canvas. So if this were 0, and this is the width of the canvas, so it goes from 0 to, let's pretend it's a 800. It's probably more than that, but anyway. So if this were 800 and this were 0, and I'm getting a number in here, I can figure out if it's on the right side, if it's more than half of 800, which would be 400. If it's more than that, it's over here. And if it's less than that, it's on the left. It's over here. And that's the two things we need to know to decide which direction the cat should pogo. So to do that, we're going to set launch direction to, the mouse position, right? We made that variable. Dot X, because we actually only need the X part of it. We don't care about the Y. The Y we get from the space bar. So the up and down where your mouse is doesn't matter at all. And minus canvas size divided by 2. Well, the X of the canvas size divided by 2. So the horizontal width, just the width divided by 2. So that's going to be the launch direction. So what we can do is set this dot target velocity. Let's see, dot X, and we can set that X component to the launch direction. And I can stop and press play. And basically my cat is now in space. We are well into space and getting further into space. And to be able to make that like a little bit more visible, one of the things I could do is I could just divide that by like 100. Like 100? Like 1,000? But this is also happening constantly, so this is like going to be impossible to see anyway. But yeah, okay. That slowed us down enough that we could see that we're going to the right. If when I started, I don't think I'm going to be able to do this. Yeah, I got my mouse there to the left. Okay, it's following my mouse sort of. Oh, yeah, that's right. Look at us. Right? And there's a game you could design with this anyway. There's some wildness to it. That's quite enjoyable. And you can see it's kind of speeds up because my mouse is further from the center. So I've got, anyway, all right, I'll stop playing with this. But like I said, we've already made an interesting game controller, and a lot of game jams is coming up with an interesting game controller. I think, the philosophy of what makes your game stand out in a game jam is really interesting. And whether or not you need it to stand out in a game jam is also interesting. But fun controllers are definitely a way to grab people very easily. Or strange controllers is another thing people like, or people remember. Okay. So let's stop the game. Go to the game camera. We'll be right back here. And we're going to make this make a little more sense. So what we're going to do now is we're going to figure out whether or not the player has released the space bar. Let me see here. That's Pogo Cat. Oh, finally. Okay. Okay. I wrote down a bunch of notes in a project, and I've got a bunch of notes in a text document, but the project one is a little more what I'm trying to see in my other, project, but this totally works. So, um, okay. So what we're gonna do is basically figure out, now I've opened too many things. We got the mouse. This is the game we're working on. This is the original Pogo Cat. This is the jam site. Okay, we're back. We're back. Okay, so what we want to do is figure out next is basically has the player I'm gonna comment this because this is a little crazy, but we can also just like see the line and we'll look at it later. Okay. So what we want to do now is figure out when the player is holding down spacebar. And that is we're going to use another game input one. So um, if okay, so we're going to do this dot game. So it's just like the input that we had here for mouse. So this is going to be this dot game dot input. I'll even copy it. Um, so we'll do this dot game dot input, and this time we're going to use the controller input and just get the main button, which was space if you're on a keyboard and is going to be like your whatever your A button type button um, controls. And it is called Action One. Action One. And if we, I'll pull up. Oh, that's why this was autocomplete. Okay, so we've got game input controls at Action One. That's basically right. The player is pressing the space bar. And so just to test it, we're going to console.log, and we're just going to say the player is pressing, and then uh, action. Okay, so let's open our console on the right here, turn off entity search, and I'm going to bring this down and play. And when I'm holding the space bar, you'll see it's taking up the player's pressing action one, and it actually doesn't stop when I release. Okay. Um, oh, it did. It did. Okay. I think something about the way that's ticking is kind of slow, so I think there's a slight delay. And that's just because I'm getting it to do something a lot over and over again. Those types of console logs are not actually what we want, right? So we don't actually want to do this, right? But what we're basically gonna say is, we're gonna get a timer. So let's make another private variable. It's gonna be called timer. Oh, sorry, not this, private timer, and it's gonna count how long the player's been holding the space bar. And basically, because this is the tick function, we need to figure out, okay, how much time is each tick taking, and then each tick add that time to return. And there's a variable for that. So if I'm gonna say this this dot underscore timer, right? And we're gonna add to it, and it's just called this dot game dot frame delta time. Not just a variable. I didn't need that. Okay. Let's go ahead. That's kind of nice. Okay. So this is just this second frame delta time. We could pull it up. Delta is the change. So it's literally how much time changed since the last frame. And that way we basically keep up with the exact amount of time because we're getting the game telling us how long the frame took. So if you're, for example, you slow down your game a lot by like say logging too many things or something ridiculous like that, then you would add more time each frame, so that player would basically have the same experience as someone who it's running at like 120 FPS per second. FPS, frame per second, not FPS per second. I may say that again though. The stream, it's just quite possible. Coffee break, tea break. Mm. Okay, everyone with me so far? I am available for questions. Um, looks like everybody's chatting in the chat and having a good time. So again, you can just throw them out there. You can throw more peripherally or even not particularly related things, just go ahead and ask. I'm here for the asking. But we're gonna keep going. So right now what we're doing is we're picking up a time. And basically we're going to keep timing, right, until you stop letting go of the controller. And okay. So we need another variable called jump impulse. Um, this is going to be basically how far we're going up. Um, is the point of it. And so we're basically the longer we hold, right, the farther we're supposed to jump. If we saw Pogo Cat, it squishes down and it goes boing if you hold it a long time, and just boop if you hold it a short time. So this is what we're timing up towards. So this one is called jump impulse, and it's going to start at 0. And each frame, we're going to add a little bit to it. Now, what I'm going to do right now, which is not a great idea, is we're just going to directly say the amount of time with the amount of impulse. And we'll fix this later, but this jump impulse equals this timer. And what we're going to do right now, tick goes all the way through. And what I want it to do is I'm going to add a bunch of logic about, like, say, like adding things to position, stuff like that. But when I'm holding down, I don't want to do anything more, right? I just want it to be holding down. And when I let go, it can do things like moving the cat and stuff like that. So to do that, I'm going to write return here. Basically, stop this function here, and then because it's tick, you're going to start it up immediately. So what it's going to do is it's going to go back to this line and down to here, and then back up to here and down to here, and it's never going to get to anything past this. And that's why I could do something like, say, set this dot timer, like a space this dot timer. I can set that back to 0, and it won't interrupt the counting, because the counting is going to keep going until I'm not holding the space bar anymore, and then it'll get back to 0. But by that time, we'll have already calculated our jump impulse, which is this dot timer. So we're going to say target velocity is this. And what we'll notice with just this return, before we even actually add any of the jump to anything, is that if I press play, no, it still shouldn't do it. If I'm here we go. If I'm holding space, it doesn't move, and then when I release, it does. Because while I'm holding space, it's not getting to that line of code. I hope my very loud keyboard is not failing me, and doing the thing that I want it to do. Okay. So that's cool. So now we wanna actually use this jump impulse here, and to do that, we're gonna do just like we did this dot target velocity dot x is the launch direction. We're gonna say this dot target underscore target velocity dot y equals jump impulse. This dot jump impulse. Okay. So now, what should happen is when I hold space bar, I get this the horizontal component is still going, but essentially we should be moving into space. One of the things we can do to kind of like maximize on this game camera, and since we're stopped, we'll do fly camera. Let's fly in here, shall we? Oh my goodness. Okay. There we go. All right. So we can is the game playing? No, it's not. Okay. This is how the game looks. Okay, here we go. Okay, so we're gonna take this. We're gonna select the game camera, and we've got that offset that we've currently got set to 60. I'm gonna set it to 1,000 so that when I press play, my Pogo Cat is very small. And that gives me a little more room to find out boom, what it's doing. And basically, this horizontal is happening all the time, and that is not what I want. Um, so okay. Alright, so let me press stop, and we'll start again, but at least it gives us some room to see it. So this whole setting the launch direction, we should do this in this section right in this. Um, so now I should not be able to change it, after I jump. We can see now we're going into space. What a gloriously excellent time. This is we're doing so well already. So the next part we need is to make the cat fall down again, right? Obviously, that's the next thing. And for this, we're actually gonna make a public variable because when we start just picking numbers, right? What speed should it go? What the maximum jump be and stuff like that, stuff that we obviously don't have yet, that we're gonna want to be able to put in a public variable so that we can adjust it if we don't like it. That's a important game dev thing, right? Tweaking. So I'm going to set gravity to -10. As you know, the acceleration due to gravity is -9.8 meters per second. So it usually ends up being 10 or 9.8 anytime I do this, even though it doesn't really apply. So that's gravity. But the thing with gravity is that, well, one, let's break this into two. Uh, Okay. We need to set this into 2 things. So, first, we need to break this up. So right now, right, we're doing the movement, um, and calculation. Actually, all of this works. So what I wanna do is, make a variable called we started on gravity. We need to make a pressed variable. So this is basically just something that's gonna calculate whether or not the space bar has been pressed. So that we've got logic that happens while you're pressing it, which needs to happen if it hasn't been pressed. Um, and then logic that happens when the button is down, and then logic that resets that. So what we have is um, when this input thing goes down, we're going to say the timer is the launch direction is the one that I don't want in here. Okay. Okay. So what we're going to do is we're going to set this dot pressed to true when basically the space bar has been pressed. Now, this is gonna keep being set to true as long as we're holding it, and, with the return, it's gonna go back to the top here and keep doing this section, and then as soon as we are no longer doing this, it's going to be, false. Ooh, okay, and okay, we're gonna set it to false, we're gonna have it do everything, right, setting the launch velocity, and then we don't want it to do it again. As you saw, let's see here, I've got it set up again. So right now, I've got the Pogo cat just continuously going up for one thing, and then also continuously following my mouse, and I only want it to do it at the moment that it launches and then no longer. So to get that, we need to say, "Okay, the game button was pressed, and then we're gonna do all of this logic once, and then we're gonna set press back to false so that, um" okay. Alright, we're doing great. This is fine. Um, so the way I have this in the example that I was doing is I have this in an else if, and this one is this dot underscore press. I think that just will make the need to return go away if we put everything else in here. Um, but that's fine. So we're going to take all of this. I think target velocity we're going to do that. So here we check, say, is the jump button pressed? And then down here, we're going to say set the target velocity for a jump. So the velocity for a jump is going to be the launch direction. I think we need to set the timer back to 0. I'm not positive if I need to do it here or not. We're going to use the same timer variable for something else, but it's pretty unrelated. Um, So we're basically always going to transform by target velocity, but we're going to make the target velocity the jumping target velocity by adding launch direction and jump pulse, setting the launch direction and jump impulse when the button is pressed. And then we're also going to say, well, it's pressed, so let's set it back to unpressed or false so that we don't keep setting it that way. And what we should see now, if we save this and save the game and press shift arrow and press play, that camera height, why I feel like it needs to be like 100. Yeah, that's better, right? So that we can hold the space bar, and when we release, we still don't have gravity. I started doing that part, but as you can see, we're no longer turning with my mouse. It just does the direction correction once. But after this, you're not going to have control. Now we nothing stops me from jumping again, and we'll work on that after we get the gravity. It's all going to be related. You'll see. So uh, let's go back to Pogo Cat controller. And now we've got the gravity. So what we wanna do with the gravity, is where do I do gravity? We're just gonna do it in this board. So we're gonna change the target velocity. So, this is why we need to set the timer back to 0. Okay. So we'll set the timer back to 0 just so I can use it for the gravity because like I said, gravity is acceleration, so I need a time variable. Okay. So, I had this anyway, it's fine. So we've got the target velocity dot y here that we're adding the jump impulse to. Um, but as long as I don't change the jump impulse, then I'm going to take this and it's going to be uh, take the gravity times the timer, and we're going to have to take up the timer again. That's what my issue is. Uh, plus the jump impulse. Okay, so these are all just numbers, so I can just add and multiply them like normal, instead of like doing dot add or dot multiply. So we need to add. We've set the timer back to 0, and we need to add to the timer again. So we're going to say this timer. We'll add to it game frame delta time. This dot game. The game that belongs to this script. Okay. So let's go ahead and see what that looks like when I press play. And we're falling. And that is what we wanted. I feel very gravity right now, right? This is extremely gravity. It's exactly what it's supposed to be doing. And if we jump, we launch up a lot. and fall down and launch up and fall down. And that's more or less what we want, besides the fact that we want it to stop when we touch the ground. And there's a pretty easy way to do that. We're gonna do this with, a different function, so it won't be the tick function. We're just literally going to check if the cat is colliding with the ground, and we can do that with on collision stay, which is, a tick function that happens when something is colliding with something else. And in this case, the built-in function has two different things, but only one we need. That's an entity called other. And that's the thing that we're touching. So for right now, we're just going to console.log. Pogo cat is colliding with, and we'll do the other dot names. We'll get the name of the entity. We're gonna see something weird that I like. So uh 12 to open the console. Here we go. So when I press play, we've just got no collision at all. Just nothing. Okay. Might have gone ahead. We need to actually make it do some logic. So what we want to do is we're going to create another variable, another private variable, and this is called grounded. And it's going to say basically we're going to keep track of whether or not PogoCat is on the ground because, for example, you shouldn't be able to press spacebar to jump again unless you're on the ground. So this is going to start out as it will be false in the end, but we're going to start it out as true just so that we can see it affecting our logic. So what we want to do is we're basically going to say, okay, so this part, if the game action, right? This is can we press the space bar? This is us pressing the space bar. So that should actually be part of if it's stuck grounded, right? We should it only matters that we press the space bar if we are grounded. So all of this is going to get indented. And we're going to do all of this logic to both calculate the jump and then make the jump happen if you are grounded. And it's only if you are not grounded, right? So that's going to be an else that you should do things like be affected by gravity. All right, so let's see what this looks like. So if I press play now, I should be able to make PogoCat. We're getting the Y command. Okay. We also need to set grounded to false when we leave the ground. So if this is pressed, we do the whole launch thing. We set the timer to 0, and we're also going to say this dot grounded is false. And that'll mean that next time we go through the tick, we're going to skip this part of the if and go to this else, which is calculate the timer and start adding some velocity to your y. And then we're adding the horizontal component regardless. I think we only want to do that if we are not grounded as well. I think we just set it to 0. We'll see. Let me remember what level of broken we're supposed to be right now. So I'll just pull this down and whoop. Okay. So what we do is we can just see that again in slow motion. We probably need a little bit more impulse. I'm gonna take this part, this jump impulse. You see it just didn't jump very high. I want to jump higher than that. So this jump impulse, I'm gonna multiply it by 10 just so that we actually see it. So when I press play, goes the other way, and I jump. Okay, that's a lot. It's based on how things but we can see that basically I was grounded. It let me jump. I can't jump again. I'm no longer jumping in the midair. But we don't actually start being grounded when we touch the ground. And that's what the on collision stay is supposed to do. So if we players pressing action one, let's get rid of that one. We did. So we should see. Okay, so let's press stop. I'm gonna clear my console here so that I can press play, and I should be able to see one, I should be colliding something wrong on collision state. Did I spell that wrong or something? 'Cause it should be colliding with the floor when I start. Alright, well, what we're gonna say is, that when you collide with something, if you were moving to begin with, so if target velocity is 0, you're not moving, and if it's less than 0, you're moving down in the way we have this range, right? So we're gonna say basically if you were moving down and you I think it's strange, it should be console logging. So I'm abusing my console log, but Pogo Cat should be colliding with the floor when it's on the floor. Okay. So basically, if our velocity is negative, right? Target velocity dot y. Oops. The y component of our velocity underscore target velocity. Um, then we are going to say, okay, well, then you're grounded. Because you hit the ground. I really we need like a counter in the corner of how many times I forget to type this in a stream. Uh, we'll just pick them up over time. I have not checked questions in a while. Let me see. Looks like everybody is having an excellent time in the working space. Probably. I hope you fill it with magnificent things. Oh, am I in it enough for you to edit it? I hope so. Uh, oh, nice, lovely to see you. Thank you. Yeah, I've definitely been major Tomming it in here, but I'm very happy to see everybody. It's wonderful. Hello, Ashley. Lovely to see you. Have you here while I butcher your code. No, it's great. You're doing fine. Okay, so now we say we're on the ground, right? And we also need to say stop moving down, right? So we'll say this target velocity dot y equals 0. We just don't want to move down anymore, right? We're going to stop it. Um, so this should stop us when we hit the ground. And something is weird. Do I not have a collider on my thing? I should have. When I did this the first time, everything was breaking and it was great. And just nothing. Just we got a weird lack of collision. Oh, you know what? Haha. Okay. I know what I did wrong. Okay. I did one thing wrong, and then I'll get to have done a second thing wrong, which I plan to do wrong, and not this thing that I didn't plan to do wrong, we did wrong anyway. So we're gonna change this collider because this is a player. If you ever look at like your collider when you're a normal skeletal object player, we use a capsule. Oh, this is what's wrong here. Um, so in this collision section right now, it's trying to use the voxel object, and what I want is a capsule so that it can kind of I don't know, it's gonna feel more natural. It's gonna have an easier time calculating when I'm touching things than trying to look at like every single little voxel on the side, right? And I think everything else is fine. So we're gonna go ahead and push that to template. And then hopefully we'll have a new different problem. Okay. So finally we have my second problem, which I planned, which has to do with the lazy way I added the other voxel object. So this says PogoCat is colliding with unnamed entity. Now, if I look in my little entity search, right, you might notice that there is something called unnamed entity, and it's actually PogoCat. So right now, PogoCat is colliding with itself. And if I were an elegant coding person, right, I might say, well, make sure that thing isn't parented to you. You can check its parent. And probably later, if we get to making this pretty, and if you look at like the original code, actually check for make sure that it's not colliding something that it is parented to. Um, so that would make sense if you need to attach it to. Anyway, what we're gonna do is we're actually just gonna change the way the second Pogo cat spawns. So, this is just kind of a fun thing to do anyway. So if you'll remember, I used this DBB spawn and parent voxel object, and what we're gonna do is we're gonna remix it, and we're gonna add the option to not have a collider on our voxel object. So we'll say update all the entities to use the new script. There's only one, it's the one that we're using, but that's fine. We're gonna make our own version. So let me rename it. We can keep it remix. We'll call this no collision. And what we're gonna do is just here in the scale, we're gonna add a new thing, and it's gonna be a boolean. So we'll say use collision. And we're gonna set it to true by default so that it basically works the same way the script does. But when I look at this, we don't need gizmo, we need spawn and pair box object. It's gonna have this new checkbox called use collision. And I'm gonna look at here is the part where we add the collision component, and I'm just gonna go in here. This is it, all I'm doing. And I'm gonna say if this dot use collision. And I'm gonna put it in this if statement. We'll put down here. And we'll indent all of this. And so what you'll see now is that basically we're just gonna, if we did uncheck use collision, which we're about to uncheck, then when it spawns, it should have a collider. I just think that's a useful thing to have. And I'm gonna just add one more little thing at the end because it keeps showing up as unnamed entity, and I am going to give it the name of the voxel object. So if we go into the API and we look up game objects is where you find entity, and you want the voxel object component. Um, and so I look it up like this, and eventually get to a voxel object component, which will eventually find me a voxel object. Where's dang daggone voxel object? This. And I'll see that voxel object, if I get into this class, this is just how I get there. I guess it's under resources. You would have found it there. How I can find that I can get the name of the voxel object, and that's like literally what like the artist named it when they made it. So I'm gonna go into here, and if I look at this code, I can see that the voxel object component, which is a voxel object component, um, here we reference the voxel object that goes with it. Um, we assign it by using voxel object, getting the voxel object that's associated with it. Anyway, so if I use does this actually do what I think it's doing? Ooh. Anyway, I'm gonna name the entity that. So I'm literally just gonna say entity dot name equals vocom dot voxel object dot. Okay, so when it says possibly null and you're not worried about it because that was the whole point of the script, you add an exclamation mark and then worry about your problems later down the road. So this should just also make it named Pogo Cat. I think Pogo Cat scalable, something like that. So I've made this change, and because it spawns, I need to restart the game for it to work, but we'll press save and we can close this other one. Probably we don't need to use it again, but we'll press play. And if I look in here, oops, stop, play, still called unnamed entity. So it didn't work, but does it have oh my god, someone in chat tell me why it didn't work. By now you've seen me do it 100,000 times. 10 points for whoever can tell me why this did not work. Magic Man, welcome to the stream, by the way. All right, there's a little bit of delay in the stream, so hopefully you'll get a chance to guess in chat, and I will pick it up when you get there. But the answer is because I didn't push the template. So we'll press stop. We'll select our thing, and it's possible spawn and parent voxel object. Is this even my new script? No collision. Okay, yes. So this is the right script. The script changes should be saved, but they just are not pushed to the template. So select the template and press save. That's now when I press play. One, it's called Pogo Cat. Boom, Pogo Cat did that. And two, it just doesn't have the collision component. So we're doing gloriously is the point of the story. So that was my kind of way of not actually dealing with it in my code and just sort of fixing it in the way things spawn. It's probably a good idea if you were making something that anybody else were using for anything to consider these cases and be able to deal with them. But yeah. So right now the Pogo Cat is not colliding with itself. If I put on my game camera, then I should be able to press space bar and oop, and we still got the horizontal part. Horizontal part goes for I don't remember how I avoided doing this. But we're just gonna stop it when it is grounded. So we can close the script out. We'll stop this for now so that we can start it over. And this uh why why did how did I do this before? Target velocity equals launch direction. When do I ever reset launch direction? Okay, we're just only gonna do this entity world transform if we are not there we go. All right, this should save it. So let's just see if we look like we've got a pogo going on. That looks pretty pogo if you ask me. It's following the direction of my mouse. It's moving a very reasonable amount. It's falling into infinity. I excellent job, everyone. We've done it. So next phase, right now that we've got the general movement, right? We've got gravity, we've got stopping. We're missing a couple things. One is probably not letting you fall into space, and two is making these numbers make any sense whatsoever. Because as you see, I've had to like back the camera up into infinity just to see what's going on, and that's because I just didn't. Let's call them sanitize. I just didn't make any of the numbers make sense. So next step is making the numbers make sense. Um, so we've got our gravity variable, and we want to add basically a maximum horizontal um, velocity. So I think that's what is that? Trying to use all the same variable names. So this is going to be max horizontal impulse, and I think in PogoCat the original. Oh, this is still the voxel object. I got to pull the PogoCat. Here's PogoCat the original. So we've got max horizontal impulse. That's at 5. Right, so we can do that. So in go. So at 5. And then we also need basically a max vertical impulse, which we're going to call max jump impulse. And that was 10. It's basically the opposite of the gravity, right? So negative, positive. That makes sense. Good place to start. Okay. So now we need to make that actually stop it. And to do the horizontal one is pretty easy. Let's see, where do we actually set the launch direction? Okay, so here you can see I'm just dividing it by 100 to make it make any sense because I was getting something like negative 400 over here and positive. Actually, we will log this. So let's just console.log. Um, so that we can see it, and this is only going to work if spacebar is pressed. But let's play, and then over here in the log, let me clear it out so we can really see. But if I'm holding spacebar, what's going on? Okay, so this is only going once when it released. Okay, so I lost my opportunity. When I my first time I rehearsed this, I had some time where we could see the numbers. But basically the canvas size, you're getting like negative 400 on one side, positive 400 on the right side, sort of like we calculated it would be. And so those numbers don't make a lot of sense when your maximum jump is uh, 10 and your maximum horizontal is supposed to be basically a hundredth of that, right? So this was approximating it reasonably well, but it's not the way we want to do this. do it, we're going to use a method called map. So if I go into the API, you found it earlier, and into the math section, we'll find something called math utils. And if I go into that, find the actual math utils, right? Uh, the interface. That's what I want. Okay, and this just gives me a bunch of functions that I can use. These come from 3JS, but I think there are differences between ours and the three right now, and interesting things to come with respect to that in the future. Okay, so what we want to do is we're going to use this one called map linear. That's basically going to say, okay, we've got this set of numbers, and we've got a number that comes within this set of numbers, and we want to take this number and make it basically in the same place, but between two different numbers. So, like, I've got a number from negative 400 to positive 400, and I want to change it into a number from negative 5 to 5. And this just says, "Yeah, just tell me the numbers, I'll give it to you. No problem," right? The first thing is the number that we're gonna change. The third second and third things are the range it's in right now, and then the fourth and fifth things are the range that we want it to be in the end. So that's what we're going to do. So we're gonna use map linear. Launch direction is here. Okay. So we're just going to change launch direction itself. So we'll say launch direction. Is that actually, or do I think that's how I did it before. We'll find out. I'm reusing more variables than perhaps we should. Okay. Yeah. We're going to change launch direction in place, which means that this version of it is going to be a changed version of what it was when it was on this line, if that makes any sense. So we'll use map utils dot map linear, and we'll give it all of our variables. So thing we want to change is ourself. It's this dot underscore launch direction. Probably wanted it to be like launch impulse or something like that, but here we are. Okay, so this dot launch direction, and then we need to give it the range that it was in before. And the range that it was in before was this canvas size from negative half the canvas size to positive half the canvas size, right? So that's negative canvas size over 2. The next negative needs to touch it. Boop. And then the other side of that range was canvas size over 2, the positive version. And then the new range is going to be this value that we just made, max horizontal impulse. And that is going to go from negative max horizontal impulse to this negative this stuff. It's another one for the this count. This is getting a little long. To positive this dot max horizontal impulse. Okay. Canvas, why is this one mad? Thinks this is not a number. What did I do? This looks the same as this one. Oh, it's because these need to be .x. Okay. We only want the width, right? And it's a vector 2, so we need to turn it into a number. Okay, cool. It was a vector 2. That's why they thought it wasn't a number, because it wasn't. You got me again, TypeScript. Okay, so this is our new launch direction, which should be a lot more reasonable. Now, before we were dividing it by 100, so it didn't look that ridiculous, but now if I press spacebar, the height's a little crazy, but horizontally, we're not actually falling off the island. Yeah, nearly as much. Okay, oh, look at that. Down we go. And deep, deep into the thing. Okay, so we're gonna stop the game, go into game camera. Um, so I would say that's a pretty reasonable launch direction that would does appear to be within the parameters that we stated. Now, yeah. So we need to do a similar thing with the uh, jump impulse. But what we're going to do is we've what I did to set this up right is I just said count how long I've been holding it and just say that's how far we're going to jump. And that's a little wild. And I'm actually then multiplying it by 10 sort of randomly down here. So let's take that out before it messes us up. But what we actually want to do is say, okay, there's a maximum height, and I want to count up how long I've been holding and basically figure out from here to like um 1 second how long you've been holding the thing and then making you jump to your maximum if it's the maximum and then down if it's less than the maximum. Okay, so to do that, we're gonna start with another math util called a clamp. So we're gonna take this out. Let's just comment that for now. So we've got our timer. And we're gonna say basically we want the timer, but we don't want you to be able to hold it for like 8 seconds and then just like do the crazy jumps like we're doing right. Right. That's not the goal. So we're actually gonna say a timer up to 1 second. And to do that, we're going to clamp it, which basically says I will count you up until a certain point, and then I stop counting you and I just call you the maximum thing. Right. So to do that, we're gonna make another variable called t, which is basically the timer but clamp. And we'll use the clamp. So let's just pull it up on here. Since we're already on the page, right? And basically you say, okay, here's the number, here's the minimum and the maximum, and I want you to give me either the number, unless it's less than the minimum, and then just give me the minimum, or it's greater than the maximum, and then just giving me the max, right? So a lot of times I just get the number, right? Which is what I want to have most of the time if you've been holding the space bar for like less than a second. Um, but otherwise, I want if it's more than a second, just tell me it's a second, and if it's less than a second, just tell me it's 0. Um, so to do that, we are going to, where was I? T mathutils dot clamp, and we're gonna clamp the timer between 0 and 1. And so now I have another variable. I didn't want to change the timer, because I think we're gonna use that for the animation. It's fine. We're gonna use it for lots of other things. Um, later on, if we actually do the squashing animation, which time-wise, maybe not, but, possibly, probably. Okay, so we've got this clamp, and that's gonna take us from 0 to 1. And now we want to basically multiply that by our max jump impulse. But there is a nicer way to multiply something that is between 0 and 1. And that's basically a lerp, which is going to kind of, I don't know, make it go sheer on its way. So we're going to say down here where we were setting this dot jump impulse to the timer, we're now going to do something more sane. And we're going to set it to a lerp. So pull it up on our math page as well. And so basically in this one, you give it a number between 0 and 1, and then, or sorry, all right, you give it a numbers that you want it to be between, and basically what percentage done you are with that, and then rather than just multiplying it, it gives you a nice number. You'll see. Um, maybe I should just do it the dumb way first so that you can say, let's try it. So math, well, we're gonna write this out and then I'm gonna change it back and we're gonna see if we can see the difference. So this dot, we're going to lerp jump impulse, right, which is what we have between this and our maximum. Oops. This should be max jump impulse. I was doing this with max horizontal impulse. Am I? Okay, max jump impulse. I literally had this horizontal and it was just working. Wild. I guess it's just a number, right? Um, and then T. So T is my kind of my number between 0 and 1 that I'm using here. And if I say, like, I wanted your well, we can figure that out later. Okay. If I So this is our jump impulse. We've got everything working, and then let's try it out and see how it feels in game. I'm holding the space bar, I let go, and I jumped very high. Now Pogo Cat goes pretty high, but I think that's higher than let's save that. What's my max jump impulse score to? All right, let's set it to 5 in here and see if that changes it or if there's something wrong with my code. Uh, okay, yeah, that was less. So with this is the whole value of being able to tweak it in the interface. You can get these little things. So we're gonna set it back to 10, because that's kind of the design of the thing that we're following, and then we can tweak it later if we want it ourselves. Okay, so now we can fix the camera too. So I'm gonna select camera and find in here, and I'm gonna set my distance. I think this is only supposed to be like 40 up, and then we'll make this like 200 away, so that that's a lot. That needs to be higher. 80? Yeah, a little more, right? So we have room to kind of see where Pogo Cat's gonna jump. Is that too high though? Yeah, that feels good. Okay. And actually, at this point, let's save and let's go check chat. Haven't done that in a while. Squid Kid. Maze, you've had collision issues. Yeah, I when in doubt, use a capsule in Big Bang. There's some kind of funny things where you would think a box would be the easiest thing because, like, if I had to write the math on how to do collision with the box, would be easier. But there's just like a lot going on in Big Bang things, especially with voxel collision, and so capsule's kind of your best bet when in doubt. So yeah, hello everyone. Good to see you all. Um, okay, so where is my okay. So we are we're back in this okay, what we were gonna do is we were gonna go out to the game and we're just gonna kinda look at how it feels, right? So I've got this the jump still feels very big, but not bad, right? I think one of the things that's hard compared to the base game is, 1, I don't have the good background, so it's looking very 3D, which makes it hard to see, whereas if you had those mountains and stuff, it'd be better stuff. There's also some logic in the, other one to, get rid of you and respawn you if you fall off the cliff. Um, yeah, so now we can kind of squish the cat using some other lerps. Oh, that's right. We were gonna test to see if it looked very different for us to just multiply this dot jump impulse. Um, and because I know T is between 0 and 1, and we're just gonna say set it to T times this dot max jump impulse. And see if that feels different or, not. So press play and then jump up. And can you kind of feel it doesn't look as I mean, maybe not. So experiment for you to try on your own. But we're gonna set it back to the lerp. Things like lerps and easings, they make I'm gonna say it, they make it juicier. Um, so we'll get rid of this first one and we'll have it set up. But it feels a little, squishier. It's sort of like zooms instead of zips. Um, okay. And so now we're gonna really get into this as we try to ease. As we try desperately to ease the, Pogo Cat, uh, thing. So we're looking at, like, what did I skip in this? So this is some multiplayer stuff that I should have added, uh, and these are also, basically, uh this is checking that the cat spawned, but because I did it in a separate script, then, you won't have it either. But we're basically you can kinda see here, this is our timer. Um, okay. And so what we're gonna do now is we're gonna squish it while we're holding down the space bar, right? Um, and this got squished scale. So do we have this got squished scale? Okay. So this is cool. So we're going to define a vector 3 that decides what when max is squished, and we are going to uh, exponentially ease into it, and I believe uh, elastically ease out of it. We can play with the easings as we get there too. Okay. So we've got this squished scale here, and I like it. So I'm just gonna pull that guy out. Um, 5, a quarter, and 1. Okay. Okay. So, because we can play with this too. So we're just gonna put this in here, and we're gonna say squish scale, and I'm just going to, set this immediately so that we can kind of, like, see what the cat should look like. Actually, we have non-uniform scaling now, so I can actually just play with it in the editor without having to do anything fancy at all. So let's take our cat. And we'll select it, and what a glorious, happy day for me, to just be doing this, and I love it. Okay, so we've got a scale, and it used to be that we had uniform scales, everything scaled like this, and you could do it in a script, you could do non-uniform scale, but you couldn't just do it in here. But now we can. So if we look at what we're trying to do, right? And this is now we're into principles of animation story. When you go up, you're gonna stretch out, that's called stretch. When you land, you're gonna squish, which is called squash. Squish for the squash. And if you look at like cartoons, you'll see a lot of things that just don't just go up and down, they go up and down. Like like putty. Um, so this is a good example for that. So what we can see here is we're gonna stretch this X. Oops, sorry. We're gonna remove uniform scale, and we're gonna stretch this X and we get wider, but we don't wanna just get wider, we wanna get wider and shorter. And I think is that really okay, this is what it gets to in the game? So sorry, this was supposed to be 5. Yeah. Alright, so that's what our maximum squash or squish is gonna look like. I love it. It's beautiful. Um, so I pat um, so we're gonna reset this in here. But let's go ahead, we can add it. We'll just do it normally. Okay, so here in the squish scale, we've got for the X, we've got 5, and for the Y, we've got 0.25. Then we're basically just like the lerp said, okay, I've got a number between 0 and 1, and I want you to apply it to a different range, right? That's kind of what everything we've been doing from the map to the clamp and things like that, right? Just saying, I need everything to work in this range with this thing. And a lot of times, right, if I were like trying to do, say, like degrees or something, suddenly I need a number between 0 and 360, right? And that's not like going to logically map to anything else. Um, Maybe it did more in which is whence comes our 360 degrees because they had a sort of a base 10, base 60 counting system. Um, but anyway, so what we're gonna do is we're gonna use an easing function to squish our scale down to, um, the max with T. So go back to cat. This is past where my last, um, went, exponential here, right? So, yeah, we're going to current scale or switch scale, and, T is gonna be how far it is. Okay. So we're gonna skip the easing for a section, and we're just gonna use a lerp. So, okay, um, this is my version of it, okay? Our version of it that we've all made together, and We're going to say, and here's the part where we're squishing. Okay, so we've got T, and we're gonna just say, um, we've got squish scale. We're gonna say, oh my god, we're just setting the transform, right? Now we've got a scale value. All right, I did not pay attention to every that works. I've got it in my notes from the first time I looked at it. Okay. Okay, so we're gonna make a scale variable, and then we're gonna to our uh, copy this to our actual scale. Which sure. Okay. So to do that, we're gonna go back in here and we'll just make another scale back. So this is a, and this is gonna equal, it's just gonna be a vector 3. This has got an x, y, and z value. New vector 3. And then as we do this, we're going to say this dot current scale equals, and then we will lerp uh, Matthew. Is it Matthew Dills or do I do this? Is this a vector function? Um, yeah, okay, so this is actually a function on the vector. So we can actually see there's a lerp here, but that's not the one we want. We want the lerp that is here, right? Because lerping with a vector is kind of fun because it'll figure out your x, y, and z from one vector to another vector. Or from one vector and a number. Okay, lerp vectors would be if I have two vectors, but I only have one vector. I have one vector and one number, and I need to get there. So current scale is going to not math equals. We're just literally going to dot lerp, and let's go back to here. What do we have? And our inputs are the squish scale, which is our vector 3 input, and then T, which is our number input, right? It's supposed to be in an interval, right, in between 0 and 1. Okay, so we're gonna lerp, and we're gonna lerp this dot squish scale and T. And then we're gonna apply that immediately afterwards. And we're just gonna copy that directly into our copy current scale. All right, let's see this work. Let's see this work in the context of this game. I hold. Nope, it went very fast. Where's my timer off? Am I using the wrong timer? Right, frame delta time is in seconds, right? All right, well, let's add the easing and see if it fixes it. Not entirely sure. What I was skipping was the. Okay, we'll add an easing. Okay, so easing functions are fun. and they don't help anything. I just don't know if that solves my thing. So we're gonna say t equals using dot. We said exponential is the one we have here. Um, and then correction. That's why it's mad dot. And we've got in, out, and in is gonna in starts slow and speeds up. I think we can look at I can pull up easing.net so we can visualize. Um, I'm gonna give it T, right? We're just reassigning it in T in place. Yeah. Okay. So now we can try that and see if that makes it any more readable, but I don't think that's what my problem is. Yeah, it's like reversed. What is happening? All right, let's check what our squished scale is because maybe we did not save that. Oh, you know what? This we'd actually have to, uh, since the values are here, but they're 1 in here. That is a case in which I need to see, here's the change. Set squish the scale to 5 wide and a quarter tall. Yeah, gotta push that. Alright, see if that helps. Press play. Yes. Okay, this is my expected behavior. So let's talk about the easing functions because I think they're really fun. Easings.net, I want easings, sorry. Okay, so here we go. So these are our easing functions, and the one that we were using was exponential in. So we can see, you see the speed of the. So this is going from 0 to 1, and it's showing you kind of how that feels. Right, and we can see ease in back kind of drops low and does a bunch of other things, but this is gonna be really, like, a clear relationship between what you do and what, sort of the input that you're giving as a player and then what the cat does. You can see a clear line. If I do something like bounce, it's not really clear how much, like, I'm controlling it. Why are you in the orange? Am I in the Okay, we'll see where I show up, and what that means. Um, but yeah, we can see that basically exponential is a really good choice because it's very clear, right? We can try quads. We can actually mess with these. It's not gonna be as easy to see. I kinda wanna, like, see if I can make it go longer just so that we can play with it, but, like, if we took and changed this to wrong one, mine, not the original. Let's go back to game camera and press stop. We're in space again, and we'll change this to, like, say, and Charlie has a, really, cool project that I have been working that just shows kind of how to build animations with these easing functions really nicely, that I think is moved over and we can find, so I might be able to pull that one up. Um, so I don't know if you could tell. We need to fix it on the other end. It sort of looks like it's going reverse, doesn't it? I guess the travel time to 1 quarter is gonna be so much faster than to 5. Anyway, okay. It's fine. Let's do the other component of it and set this back to, exponential. Yeah. And we can see from Pogo that the other half of it happens, down here, right? And we've basically got the same thing. We are clamping T. We've got a timer. We're clamping it, and then we're just gonna do quadratic out. But this one is from 0 to 1, and was this one from 1 to 0? 0 to 0 to 1. Okay. Um, and Okay, initial scale. So we need to save initial scale somewhere, right? Let's look at where we save that. So it starts out as 1.1, and then here in the start function, we copy it. So in case I wanted to change what Pogo Cat is, we can make sure that it is the same thing. I could, if I wanted to do a very irresponsible, let's do a very irresponsible version of this. So where this happens, the descaling happens in the when we're no longer grounded, right? If grounded, else, and that's what we do. Okay. So we'll go into ours, and we've got basically an if grounded, and here's our else. So this is where we're going to fix it. And we've got a T here, and so we can just do the same thing. We can say let T equal a clamp of the. Do we need to clamp it? I mean, do we need to? Okay. So I'm sort of worried about what happens if we don't get to our scale. But anyway, I guess we probably will. Um, okay, it doesn't matter. It'll look funny and ridiculous. And then so we're gonna do a different easing. So this one we did exponential in, and this next one is going to be, I think, it wasn't elastic. Let's just try elastic out. So we'll do easing dot elastic out of t, right? And then we're gonna apply it to the scale, and we're just gonna say the scale is 1. So all right. Okay. So we made a new vector 3 whose all values are 1. We just sort of like hard set it. So this is where we would have said what our initial scale is as a responsible group of people. But we've got about 10 minutes left, and I do want to jump back into the space. Um, so we've got current scale.lerp, new vector to t, and this should go back out as we are going. So let's see if we restore our cat. Then we can really start playing with these variables. Okay. So press space. That is just not right, and I don't say this. This is the gravitying is happening. Oh, I didn't apply current scale to the scale. Okay, so we can actually just copy that line from here, which says make the actual scale the actual thing. This is a variable we say for current scale. I probably, if I were maximizing my laziness, would have even skipped having a current scale. It's useful for like later things that you need to control, but huh. All right. Where are we? All right. Scale 1 does not look like it's working out for us, but wait, I didn't have a second valuable variable, did I? Oh, wait, I want to do this. Come back. Shrink down. Fit in the screen. I need a fast reset to how it is before I mess up during it. Uh, I am not sure. Hello, Bray Domino. Welcome to the stream. We are coding. This project is going to be remixable, so people can pick apart what I did, or you can look at the original one um, and see what we're working on. This is a How to make a custom player controller in .Big Bang. Should be good stuff. Okay. Yeah, something is not easing correctly with that, but at least we're getting back to normal. Uh Yeah, okay, this feels actually pretty good. So last thing we need to do is we need to kill Pogo Cat. We need to respawn Pogo Cat when it passes a certain height, which you kind of already do if you're with your default player controller. But you can see here it's like the first thing that happens is basically if you're over less than the kill height, we're going to respawn you. So I'm just gonna copy that in because we have limited time. But okay. Um, so we need a this dot kill height, um, equals 0 here. Absolutely. Let's just set it to negative 100 might even be enough because I don't think you go below that. So let's press stop and play and see if when we fall off, we respawn or do we just die forever? I need the respawn script. Okay. So we'll stop. We'll go to this guy and that tells it what to do when it is sent to the respawn is dbb spawn. No, respawn. Let's just see what it is on Pogo Cat because Pogo Cat has default respawn. There we go. Boom. So we can add that one in and it'll do my respawn logic, hopefully. So now when I press play, solving the primary problem here, which is we respawn, respawn, respawn. Why didn't it happen? Because I didn't push it to the template because it didn't. That's another tick that we need. Very flat cats. Yes. Cats love to be flat. They're actually liquid. Um, we're like one of those contradictions, like cornstarch. Cornstarch is both solid and a liquid. That's what a cat is. So now we've pushed the template. So when I press play, I should be able to jump off the edge and die. Okay, it went to the last safe spot, which I guess is fine. That's a little funny. Our whole concept of ground is a little bit messed up now. Okay, good enough for government work. Okay, so what else would we want to do to be able to finish this out? We really look at like a Pogo Cat game and Fly Camera, right? One, um, let's check. The scale of the ground is actually scale is the same. See if I can check ground. It's 60/60, which is I think is what it normally is. I don't know why mine feels not like that. Let's check ground on ours. Scale-wise, yes, it's the same scale of ground, so maybe we do need to tweak those values of things like that, but we can also see here that we've got some background mountains. We didn't do the coin pick up. There's a we could actually just throw in the collectibles that we did for Monday would be like the lazy way to do it. Hello, where's the pancake? A question that I am also asking myself right now. Welcome to, unfortunately, the very end of this stream. You've got a question, please. Is it where's the pancake? Is that the question? I'm hanging on the edge of my seat, but I do need to throw in some background things. So there's lots of really cool options for background things. Let's actually name this project. So we'll name this Zaz makes Pogo Cat. So you can find it that way. You can search for it for that. Let's see if we can get a better. Let's do this for a thumbnail, right? New thumbnail. Boom. Pogo Cat. Centered. New thumbnail. Boom. Pogo Cat. All right. So we'll save that. We are published and remixable, so everybody can find. How come the has tons of players, but there's like 9 people watching? So because Pogo Cat. Yes, Pogo Cat. So the game that I'm in, right, and maybe some more people are in the thing. We can jump in together. But basically, there's a lot of places making Pogo Cat, but pancake Pogo Cat. Oh, pancake! You're a pancake, and the Pogo Cat pancakes. So this was meant to be. Thank you. So yeah, it just this is. I swear this is not LARPing correctly. See, it looks fine after the first time, right? Like that's the squish that we're looking for. That's my pancake. That's what we got going on. We're going off the edge and dying and going to relative safety. So we've got that. We could add some background objects. So if I go to voxel objects and all, and look for I think background is the thing that gave me the best options. But we've got some really ones. So like a city skyline, we could put Pogo Cat in a city. Little urban Pogo Cat. There's one with pine trees that saw summer used before, or we could do mountains just like we had, but, okay, so we'll put, like, town background from here, so this will be, like, so I'm gonna take this, like, silhouette-y one, and I'm gonna make it massive. Let's go into fly camera so we're not stuck here. Just okay, let's go ahead and stop the game so PogoCat does not launch into infinity. So we can take this and make it really I guess I want it really huge and really far back. Maybe I just didn't want it that big and that was wrong because that's how perspective works. So we'll make this one say bigger and we'll holding control and shift to drag out multiple ones. And then let me become a pogo cat and press F and see that I cannot see my city skyline at all. So we can take these and we can put them, select them both, and move tool, and we can stick them further back. We've got the city, which might need to be taller or something. Let's go back into pogo perspective. Yeah, it doesn't need it just needs to be bigger. 4, and now we've got non-uniform scaling, and I used to just grab anywhere on the tool. So we want some like background thing. And we can you can't select so by default, you can't select the ground. Jack Andrew, highly cool stuff. Um, you crop the picture of PogoCat. Well, you can have PogoCat. You can, 1, remix this game. Let me drop this link into everything so people can see it. You can actually make your own copy of this game. Um, just changing PogoCat, adding more PogoCats. You could pancake many things. There's a lot of options here. I'm just not getting this parallax right. I should not have tried to do this on the fly. These things are very confusing to me often. Anyway, to change where the ground is, which is something I can do, I can, I'm gonna go into entity search and select the ground that way, and then you can move it just fine. And I don't really need it as far forward as it is. So that helps me cover the city and we can move it down, probably continually make it larger until it makes sense. I don't know. Let's be a poker cat and see if this is okay, sort of city like. I'm gonna take these. I'm gonna control shift and duplicate. Sorry, you have to have the multiple ones. So that's one. Um, I don't know. Where did that city go? Far away. All right, I'm gonna delete it. Gonna delete it and go back to the first one, or the first one, and then do control shift and move that guy over there. And then I'm gonna select all three. And I'm going to kind of gray them out because they look too cheery. And I'm gonna do that in the voxel object section, basically by making the color a little gray, like this, and then I'm gonna make the emissive a little bit white, and that's gonna kind of like desaturate them, is sort of what we're going for here. And I'm not exactly sure what the goal was here. It was not for let's see, that's kind of moody. And maybe we can even replace the ground with I think there's like just a gray version of the exact same ground. Um, sorry, in my last frantic attempts to turn this into something, usually when I change ground, it messes up the collision you will probably experience, but ground. There's like just a black version. Is it me asphalt? Is that what I want? Yeah, okay. Oh no, this is a different thing, but okay. It gets my this is our gritty gritty, dark Pogo cat. I think, my whole understanding of where things needed to be is wrong. Let's look at the game. Yeah, okay, so all of that needs to move forward, and then the background, I don't know. This is kind of exactly what I wanted it to be, so, let's select all 3 of these, we put our multi-tool on, and our fly camera so that we can both move it down and a bit, forward. A bit more forward, and we're gonna have, yeah, gritty urban polka dot, move that forward too, and no game camera, what are we looking at? Okay, that's more it. I'm saving it, I'm calling it good. What else do we have? Um, hello, Jack Andrew, will you get to the game this person is making? Um Everybody don't be mean. I think that's a good thing. Is this gonna be like Super Mario Bros? It's so funny. I've been comparing things to Super Mario and things like that. You can make anything you want in this. So we are working on you make a game right now. If you make things in Big Bang, I'm working on having more streams in the future where I just show off stuff that people have made because it's like the best. I'm so glad everybody loves Pogo Cat so much. I hope Pogo Cat's creator gets to see this, for I am but a vessel for the this is actually okay, this looks exactly like what I wanted it to look like. Look at this, okay, you can tell somebody didn't know how to set up the parallax. Parallax being basically I'm faking it by having I guess or parallax is faking the effect of having some things be far in the background and some things be in the front, and so, yeah, my seams are a little too obvious, but I think the dream of flying above the city this is like Spider-Man Pogo Cat. Spider Cat. Pogo Spider Cat. Pogo Spider Cat. And anyway, I'm over time, so thank you everybody for joining me. It's been so good to see everybody here. I will, this is the remixable version I will drop in, both of my chats for you all. So you can get into the exact game that I made, you can make your own copy. Actually, if you get into it right now, you can change the one that I'm in, which I probably should have given you all time to, rain destruction upon it. We didn't get there. I hope somebody makes a much prettier version of this, and don't forget you can change out the Pogo Cat. If you didn't see the beginning, you can rewind to the beginning to make sure that you get, like, all of the art correct, because there's a little bit you have to do to make sure that it's Pogo Cat. But other than that, this is very easy to reskin and turn into something. And everything we learned here, you can use to make a variety of different 2D experiences. You could just use this to figure out how you want to make your own completely random player controller and things like that. I wanted to do like a whole rolling ball thing and things like that. Pancake's got another idea. I am very excited for the future. Thank you all so much for joining me. It's been a very fun stream. Um, and I will coming up tomorrow is Pogo Cat. I know, right? Pogo Cat is worth. I would do anything for Pogo Cat. Pogo Cat is life. Yeah, so tomorrow at the same time, so starting at whatever you are, subtract 2 hours is when this starts, and ending at about right now, wherever you are, but tomorrow, um, Summer Sky will be back. She was here yesterday, and she's gonna be back again, and she's gonna be building environments. So everything that I was really struggling to do just now, I'm like, "How do I make this look a certain way?" And I have an idea, but it's not turning out, right? All of that we have a genius of doing that really well, and Summer's gonna do it for you. So come tomorrow, and then on Friday is going to be Charlie showing us all of the glorious stuff that he has made for us to give players and make little things and understand how networking and persistence and all these fun things work in Big Bang. So it's going to be great for making your games have more retention in the long term, give people a reason to come back, things like that. That is what being able to save player data really does for you, and a bunch of other cool stuff. So that glorious things in the future. Join our Discord if you're not in it already, and you can talk to me there. You can talk to Ashley, who made this there. You can talk to lots of cool people who will tell you how to make cool stuff on your own. So we'll be very excited to see you there. And that is all I have for you. I will see you in the future.